Hi guys, we are going to go on ahead and continue on with thermochemistry with our last topic for this unit, which is what's known as Hess's Law. All right, so we just covered in our last notes how to use an enthalpy of reaction or a heat of reaction, that delta H, in a stoichiometry problem. All right, to figure out how much heat is associated with a specific reaction. Well, sometimes you don't have necessarily the delta H for the reaction you want, all right? But you can find delta H's for a bunch of different reactions that add up to what you want. And this is what's known as Hess's law of heat summation. If you add two or more thermochemical equations to give a final equation, then you can also add the heats of reaction to give the final heat of reaction. So let's take a look at what this is going to look like. All right, so here's our first example, and sorry if some of your notes, the arrows, the formatting got a little funny. Calculate the heat of reaction for the following. So this reaction is what we are interested in, all right? I have two carbon monoxides reacting with one oxygen gas to give me two carbon dioxides. Great. I need to know what the delta H for this reaction is going to be. I'm going to use these two equations that were given to me, and the delta H's were given as well. First thing you want to do with any of these is make sure that things line up. And by that, I mean make sure that your reactants in the one you want match the reactants in the one that I give you. And in this case, so I'm going to say to myself, all right, well, carbon monoxide, it's on the left side. It's a reactant. Down here, carbon monoxide is also a reactant, so that's good. Oxygen, it's a reactant. All right, great. Oxygen is also a reactant in what was given to you. Carbon dioxide is a product. Well, great. Carbon dioxide is a product in both of the ones that were given to you. Perfect. All right, you may notice that you have something extra here that's not in your reaction above. That's absolutely fine. Those are intermediates. It happens all of the time. All right, and so in this situation, you just want to make sure that they cancel out. I have one carbon on my reactant side. I have one carbon on my product. They cancel out. I am then left with two carbon monoxides. Check, two carbon monoxides. One oxygen, check. Carbon dioxide and carbon dioxide, 1, 2, and I have two carbon dioxides. Great. I'm then just going to take my calculator out and I'm going to add those two together. Remember, you have to keep those signs. So negative, I'll just let you guys do that, 393.5 plus negative 172.5. And you should get delta H for this reaction of negative 566.0 kilojoules. Great, nice and easy, all right? Now, they're not always gonna be this straightforward, so let's look at ones that are a little bit more fun, all right? Here we go with our barium reaction here, all right? We're gonna take a look at this and go through the same steps. This is the reaction I'm interested in, all right? This is the one I need to get to. These were the delta H's that were given to me. So let's check to see if things are on the correct side. Barium oxide, that looks good. Sulfuric acid. Oh, well, down here, sulfuric acid is a product. I don't want it as a product. I need it as a reactant. It's fine. What I'm going to do, though, is I'm going to flip it around. And I like to rewrite these just to make sure, all right, that things are looking right. So I'm just going to do the reverse of this reaction, which is fine. The delta H, however, for the reverse reaction is going to be positive 78.2. So please make sure if you flip the equation, you have to flip the sign of your delta H. Once I've done that, I'm going to cross this out. I'm not looking at this one anymore. I'm just looking at what I have left over. All right, sulfuric acid, fantastic. So my barium oxide looks good. My sulfuric acid looks good. My product, barium sulfate, is also on the product. Water. All right, what's not showing up there is SO3, but that's okay because I have it on the left side of the arrow and the right. So those cancel out. I'm then just going to go ahead and add those two up. All right, and so we're going to see what that looks like. So that's negative 213.4 plus 78.2. And so that your total delta H for this reaction is negative 135.2 kilojoules. All right, Fantastic. All right. Finally, you might have to do even more, and this is going to be our last example. Here is the reaction we are going for. Here are the amounts that I gave you. All right. So I actually listed your different steps here. Align the equations based on reactants products. So let's go through and do that. All right away, FTO3, all right. My iron oxide there is on the wrong side. So I'm gonna go ahead and rewrite that. I'll rewrite it up top here. So I'm gonna go 2Fe plus 3CO2 is gonna give me Fe2O3 plus 3CO. And then remember this delta H now is, instead of negative, it's positive 26.74. I'm then going to cross this out because I don't want to deal with this anymore. Okay, great. All right, so far, so now my Fe looks good, good. O2 is a reactant, and it is a reactant here, so that's fine. Fe2O3 is a product, fantastic. All right, and I'm feeling the CO is going to go away. Okay, so I have aligned the equations. You're now going to multiply based on final reaction. Now, what do I mean by that? You have to make sure that the coefficients match as well. So let's take a look. All right, so let's look at my reactants. 2 irons, 2 ions. That looks great. All right, I have 1.5 oxygens. I know that seems a little weird, but it happens with Hess's Law problems, so just go with it. All right, so 1.5 up here, but I only have half of an oxygen gas down here. So I'm going to multiply to get 1.5 to be, to get a half to be 1.5. And what am I gonna multiply that? To get that, I'm gonna multiply this whole thing by 3, which I'm totally allowed to do. But if I multiply the equation by 3, I have to multiply the delta H by 3. So that's gonna give me 3CO plus 1.5O2, and that's gonna give me 3CO2. I'm gonna have to remember over here that this is times 3 when I do my addition. I'm gonna cross this off because I don't want it anymore. And now I'm gonna see if everything works out. I have 2Fe plus 1.5 O2, great. So yes, is gonna yield Fe2O3. I have some extra stuff going on here. I have 3CO as a product and 3CO as a reactant. They go away. I have 3CO2 as a reactant and then 3CO2 as a product. They go away. So I'm just left with exactly what I'm looking for. I'm gonna go ahead, punch that into my calculator, and you should get about negative 822 kilojoules, all right? You should now go on ahead and do your practice sheet for Hess's Law. These are fun, they're like puzzles to fill out, and certainly email with any questions. Have a great day.